In this chapter, we're going to dive into the unseen scaffolding of the digital world. We're talking about the crucial technical infrastructure that allows these massive global open source projects to actually work. We'll look at the tools and the workflows that let thousands of contributors collaborate without, well, everything descending into total chaos.
So, to really get why this infrastructure is so important, we have to start with a classic problem in software development. It's a paradox that's been around for decades. Imagine you've got a project and it's running late. Your first instinct, right, is to throw more people at it to speed things up. But somehow, more often than not, that just makes it even later. So why does that happen?
Well, the answer comes from something called Brooks' Law, which was laid out in the book The Mythical Man-Month way back in 1975. The author, Fred Brooks, pointed out that when you add people to a team, the number of communication lines between them just explodes. Think about it. With 3 people, you have 3 communication paths. Add a 4th person and you jump to 6. By the time you have 10 people, you're at 45 channels. Pretty soon, everybody is spending all their time just trying to stay in sync with each other instead of actually doing the work. That communication overhead is the real beast you have to tame in any big project. So how in the world do open source projects with hundreds, maybe even thousands of contributors get around this? The solution isn't just about writing cleaner code, it's about building a really structured system for managing all that communication. And this quote just nails it. It's like parliamentary procedure. You know, the formal rules that let large groups have productive debates? Open source projects do the same thing, but with a whole suite of specialized tools to make sure every conversation is efficient, recorded, and crystal clear.
Okay, so let's start breaking this system down. We're going to begin with the most fundamental pieces of the structure, the digital foundation. These are the solid, stable parts of the project that act as the single source of truth.
So every big project really stands on 2 pillars. On one hand, you have the project website. This is its public face, its welcome mat. It's where new people come to get downloads and read the documentation. It's basically a one-way broadcast of information. But then you have the version control system. And if the website is the public face, the version control system is the private workshop. This is the single authoritative source for every line of code and its entire history. It's not just for storage, it's the engine through which all change happens. A version control system, or VCS, is the absolute heart of any software project. The best way to think about it is like an indestructible lab notebook for the project. It meticulously logs every single change, who made it, when they made it, and why. Having this perfect history lets teams experiment without being afraid of breaking things because you can always go back. It is, without a doubt, the central coordinating force for all development.
Now, to use a VCS, you just need to know a few key actions. Think of it like working on a group paper in a shared online document. A commit is like saving a version of your changes to your own computer. It's a snapshot. You then push your saved work up to the shared folder so everyone else can see it, and you pull down their latest changes to keep your copy up to date. But the real magic is in branching. Imagine you want to try writing a new chapter without messing up the main document. You'd create a copy to work on. That's a branch. It's totally isolated. Then once you're happy with your new chapter, you merge it back into the main document. This whole workflow is what lets dozens of developers work on the same project at the same time without tripping over each other.
So if version control is the project's long-term memory, then the communication hub is its central nervous system. This is where all the day-to-day discussion, debate, and coordination actually happens. Projects typically use a few different tools that work together, each one designed for a different kind of conversation. For those big, deep discussions and official announcements, they use mailing lists. This is what we call asynchronous. People can respond whenever they have time. Then, for tracking specific tasks and bugs, they have a bug tracker, which is also asynchronous. And finally, for quick questions or informal chats, they use real-time chat. That's synchronous. Everyone's online and talking at the same time.
Now, mailing lists, or these days web forms, are what's known as the project's medium of record. And this is a really important concept. It means that any discussion that matters, whether it's about a new feature or a major decision, happens right there, in public. Everything gets archived and becomes searchable. This creates a complete public history of the project's life. That kind of transparency is absolutely essential for building trust and letting new people get up to speed on why things are the way they are.
Next up is the bug tracker. Although, honestly, a better name is probably issue tracker because it's used for so much more than just bugs. It's basically a big database for any piece of work that needs doing. It could be a small typo fix, or it could be a request for a huge new feature. This system is amazing because it turns abstract ideas and problems into concrete, trackable units of work, which are usually called tickets.
And each of these tickets moves through a very predictable life cycle, which makes everything really clear for the whole community. It all starts when a ticket gets filed. Then the next crucial step is for someone else to try and reproduce the issue, just to confirm it's a real problem. After that, a developer can diagnose the cause, they'll commit a fix, and finally the ticket is closed. This simple, transparent process brings order to what could easily be a chaotic flood of requests and feedback.
All right, so we've got our code foundation and version control, and we've got our channels for communication. Now let's put it all together and see how these tools create the modern workflow for actually contributing code to a project.
The key mechanism in modern open source is something called the pull request, or PR for short. Now, the name can be a little bit confusing at first. It's not a request for you to pull something down. It's a request for the project to pull your changes from you into their code base. A contributor bundles up their changes, say a new feature or a bug fix, and presents it to the project so it can be reviewed and discussed. It's the standard formal way to propose any change.
This process follows a really clear logical path. First, a contributor makes their own copy of the project that's a clone and makes their changes on a separate branch. They then push that branch up to a public spot and open a pull request. And this is where the magic really happens. It kicks off this whole phase of review and discussion. Other developers will look at the code, they'll test it, suggest improvements, ask questions. This peer review process is right at the heart of quality control in open source. And only when everyone agrees that it's ready is the change finally merged into the official project.
And that last step, the merge, is so important. It's more than just a technical action. It's a really profound social one. See, before the merge, that code was the individual contributor's responsibility. But the instant it gets merged, it becomes the collective responsibility of the entire project. The project is basically saying, we accept this, we will take care of it, we will fix bugs in it, and we will own it from now on. That signifies a really deep level of trust and shared ownership.
Okay, so beyond that core infrastructure for code and communication, successful projects often use other tools to help manage knowledge and support their bigger community of users.
Two really common tools you'll see are wikis and Q&A forums. A wiki is a space for creating shared, structured documentation. It's like the official project handbook, and the community helps write and maintain it. The goal is to create one single, official source of information. Q&A forums, like Stack Overflow, do something different. They act as a dynamic, community-driven help desk designed to handle a ton of very specific user questions efficiently. You could say one builds a library while the other runs a support line. So finally, let's just take a step back and ask the big question. What is the ultimate purpose of all this complex infrastructure? We've talked about all these tools and processes, but why go to all this trouble? It's really not just about the technology.
This quote just illustrates the real takeaway so brilliantly. The goal of this entire system isn't just to manage code, it's to manage human interaction. All of these tools, the version control, the issue trackers, the pull requests, they're designed to create a system where people can easily and effectively express their care. Care for the project, care for the quality of the code, and care for each other's work. They create pathways for constructive feedback and make sure every contribution is seen and appreciated. So, to wrap it all up, this technical scaffolding is the invisible engine that makes open source run. It solves the massive problem of scale by putting structure around communication. It creates a digital commons, a shared workshop where anyone can contribute. It bakes peer review right into the development process itself, which ensures quality. And maybe most importantly, it helps foster a community that's built on transparency, trust, and mutual respect. And that is what allows a group of strangers, scattered all over the globe, to come together and build some of the most complex, reliable software the world has ever seen.
And that leaves us with one final, broader thought. You know, these principles we've discussed of structured communication, transparent processes, and enabling collaboration, they aren't just for software. So the real question to think about is, how can we apply these lessons in other areas? How can we design systems for all of our collaborative work in science, in business, in our communities that are optimized not just for getting things done, but for encouraging and empowering human care? It's a powerful idea to think about. Thanks for listening.